Hello guys. Berev, namaste, bonjour, melang, goeiemorgen. Anyway, I hope you did watch my previous video where I was explaining voltage dividers. I hope you did. So today, I will open a schematic, a laptop schematic. I have one here. This is, what is this? Okay, so this is what's happened here. We have a chip here generating the 3.3 and the 5 volts. Okay, this will drive you really crazy. We have those two MOSFETs there on top, generating what? 3.3 and generating 5 volts. And let's say you're struggling, you have tried everything, but nothing works. Okay, you have tried until you faint. Nothing works. Okay, you are trying, but nothing seems to be fine. Sometimes you will be surprised that the only problem you have is just a voltage divider. Okay, but this is where the 5 volts always is generated, and on the other side is where the 3.3 volts is generated. So here, when you check, we have what? We have a voltage divider. Let's go back to our thing to write this voltage divider down correct and calculate volt that should be here on feedback for 5 volts. I don't think it will be 5. I don't think it's gonna be 5 volts. I'm not saying it won't, but judging by this, since we have a voltage divider here, you know what voltage divider does, right? They reduce what? They reduce the volts. Okay. This is so interesting. Okay, this is pin number 9 on the chip that generates 3.3 volts and 5 volts. On pin number 9, what voltage we should have there? Since we have a voltage divide, of what? Of 5 volts always. What volt we should have here on pin number 9? And anyway, by the way, this is a chip that generates the 3.3 and the 5 volts. This is how it looks on the real life. Don't be confused. Looks like this. Show if I will get pictures. Okay, let's remove this. Okay, there it is. It's gonna look like this. Anyway, this is an old board then it means, because new motherboard don't use these chips. It means this is an old motherboard. So in case you are dealing with that schematic or with that laptop, you will have to find this chip for 3.3 and 5 volts. It looks exactly like this. All right, so anyway, let's go back. Going back now. Sorry about that. Oh, where's my back? Okay, my question is again on pin number 9, what volts we should have there, since we have a voltage divide. Number 9. Okay, let's draw this voltage divider. Okay, there we have something like this. Okay, shit. We have something like this actually. So here on VS, voltage source, we know the voltage source there. 5 volts always. 5 volts always. That's our source. And then we have what? We have the first resistor, R1, where they connect, and we have R2. R2 is connected to ground as always. And my answer was, what will be the voltage out? Since we have 5 volts there, it looks exactly like that. Let me show you again. There it is. This is the structure. And what do we know about the R1? R1 R1 is gonna be the resistor on the source. It's 10.5. Okay, I'm writing this down. And R2, the voltage on the ground, gonna be 6.81 A. All right, let's go back. Okay, 10.5 and then 6.81 if I'm not mistaken. Yeah, 10.5 kilo ohms, and then the other one is 6.81. So what will be the volts there, since we have the voltage on pin number 1? So to calculate this, okay, we know our formula. VO, voltage out, is gonna be voltage source by R2 divided by R1 plus R2. So this is gonna be R2 6,800. It's 110. And R1 is gonna be 10,500 plus 6,810. Okay, wait, got something. We have 5 volts here. VS, there is VS is 5 volts. Put 5 in there. So you're gonna have 5 volts times there on the thing you will have 6. Okay, so 6,810, right? Divide by, okay, now let's calculate this. Sorry about that. Let's say 10,000 500 plus 6,810. The answer is 17,310. If it's gonna be 5 times, then let's divide this. Okay, let me repeat again because we have to be sure that you don't do any mistake. Okay, plus 6,810. Yeah, correct. To do 6,810 divide by 17,310. The answer is 0.39. 0.39. Is 0.39. So this is how it's gonna go. Now we multiply. We say 5 volts times 0.39. Okay, there we're gonna have like 2 volts each one. Yes, there we're gonna have 2 volts. This is 1.95 volts. More like 2. Done. Not sure if I'm right or wrong, but there we'll have 2 volts. So V out is gonna be 2 volts. Go back on the schematic and see. Okay, so here on FB2 we'll have how many volts? 2 volts. Okay, it's even correct because this is so interesting here, and I give you a hint too. That's voltage feedback, to what 2 volts. And when we check this, what we're calculating right now, pin number one, these are what? These are feedback voltage. This is feedback voltage. Okay, let me explain this a little bit. Remember, we talked about the feedback. That's feedback is the signal. They normally senses the output. They need to know how many voltage chip generating. They send this signal here, but here they give some sort of what? A voltage divide. It means if this is not 2 volts, then the whole thing will not work. Okay, this is how they send signal. Let me write this down. It's gonna make more sense. Okay. Okay. So the feedback is more like this. I check this out. Okay. I'm so happy. This is so interesting. Okay, this is so interesting. I like what they did there. As I like their technology there. This is your max chip generating 3.3 and 5 volts, right? So you will have those two MOSFETs, one to ground, one to 19 volts as always, right? And then they connect there. This one goes, okay, this one goes to a chip somewhere. This is an output, and then this is the coil, and then there we go. Even here we have two MOSFETs. Next, one connecting to ground, one connecting to a source, to a VS, 19 volts, and then they connect here, and this is an output. After an output, go straight where? Then you'll have your sources out, your V out. Voltage out will be 3.3 here, right? Volt. Here you'll have 5 volts, right? So this chip, to make sure that these voltages are generated correctly, they send a feedback FB, feedback 5. Feedback 5, it means feedback for voltage 5. It's the one that we were calculating. Then here we'll have what? Feedback. We'll have FB3. So those signals go like this, and then they connect down here. But remember, it wasn't directly like this, right? They put what? Resistors, one to ground. You know how this thing was done, right? The one that we're calculating, the voltage divide. So this entire thing is give them what? 2 volts. Give them 2 volts, reporting to the chip. I'm pretty sure there's even a formula saying if this is greater than 2 volts, then shut down the entire thing. Or if this is less than 2 volts, maybe 0 volts, 0.5, then shut down the entire thing. Or try to correct the speed, the way those MOSFET switches. You understand? It's more like a correction pin. It was like this. It was a resistor 1, and then you have resistor 2 to ground. This thing was going like this, then it goes back and reports here. Checking this 5 volts as we calculated on our calculation. There it was. There it was. This is this reporting to the chip. Okay. Anyway, this is lovely. This is nice. You can also, I'm giving you a homework. There is your homework. Go calculate this. If you get what? 2 volts. Like this. Okay, anyway, let me just do it for you because I know you will be lazy somehow.